With the recent release of VEX Change Up, I've noticed an increased amount of discussion and questions about ratchets. That's why today I want to go over ratchets, how they work, and how they can be effectively implemented on a VRC robot. Here we have the first and most common style of VEX Ratchet. It has an internal arm that does the ratcheting, and the way that this works is there's a rubber band that's pulling the arm that's off to one side a little bit down across the center of the gear, and the gear is free spinning on the shaft and the little sprocket is locked to the shaft. If it spins this way, this will click over before spinning. It will not spin this shaft here. However, if this spins the other way, it will force this shaft around. This style of ratchet is mainly used for systems that can spin both ways. However, you only want the power going in one way. Here we have the second kind of ratchet that I've seen used in VEX. It has an external arm that's doing the ratcheting, as opposed to an arm on the inside of the system. This kind of ratchet is usually used for systems that you don't want to be able to spin it all going one way. For example, this bar would be hard mounted to your chassis or something, and this can spin this way, but it physically cannot go back the other way. And its other main use is like an arm that you want to be able to power going one way, but want to be able to have it go passively going the other way. These are the two main styles of ratchet that you're going to see, and now let's go on to some uses for them on a VRC robot. Here we have a system that uses ratchets to allow only one motor to spin two completely separate subsystems. A device very similar to this one was included on the animated reveal that I posted about a week ago. In that reveal, you can see that there is one motor that is hard mounted and constantly spins, the flywheel system, and then there's a second motor at the back that most of the time is assisting with spinning the indexer system. However, it occasionally also has the responsibility to power the trapdoor at the back of the robot. If I hit this button here, the motor spins in one way, spinning the indexer. If I hit a different button, the motor spins in the other way, and it moves up this bar until it runs into this limit switch. If we take a look here, the motor is constantly spinning this shaft here, it's constantly spinning this chain, and it's also constantly spinning this gear here, which means that this gear here is also spinning. This pinion here is not. Here we have one of the ratchets that I talked about at the beginning of the video on there. This is always wanting to get pushed down into the pinion, but the pinion pushes this up when this spins around that way. When this motor spins this way, it forces the screw to spin around the pinion, but when it spins the other way, it just lets this screw click around the pinion, so even when this is all the way down at the bottom, this can keep spinning without this running to the issue that it's hard stopped at the bottom. This lets this continue to spin. What we also have here is a rubber band that, when there's not force from the motor holding this up, pulls this bar back down. Then if we go and take a look at the other side here, you can see that we have a slightly different system. We have the chain that's constantly spinning this system here. It's not always spinning the shaft here, but it is always spinning the sprocket. I have linked this sprocket and this gear, so these always spin together. They are free spinning on the shaft here, but these can't spin apart from each other. I'll go more into how I did that later. Here we have another one of the system with a pinion, and the advantage to using a pinion rather than a 6-tooth sprocket for the ratchets are it's more precise. As you can see, the amount of distance that this will go before clicking is much smaller than it did on the 6-tooth sprocket earlier in the video. So this can spin here, and it powers this wheel. But then, if this starts spinning in the other way, the wheel can keep on spinning this way, and it's not going to break anything else in the system if the other motor that's constantly powering this indexer to spin this way is left on. So we can always have power on here through the other motor that's going to be on the system, but most of the time we can have that motor being assisted by this motor, except for when it needs to take a break from powering the indexer and go and power the trapdoor bar. That's how this system works. Let's go take a look at a different kind of ratchet. Here we have the second kind of ratchet that I'm going to be going over in this video, and interestingly enough, my dog has decided that he'd like to join me while I'm filming this video, so he's going to be around for a while. He's a good boy. Okay. So the way that this works is it's an intake system that can be powered like that, and it can spin in like this, but only with one motor per side. If I hit this button here, the motors spin one way, they spin inwards, and if I spin the motors the other way, the intakes can fold back like that. There are a couple benefits to this. One being, at the start of the match, I can have the intake motors be holding the arms back to help keep it inside the 18 by 18 inch size restriction, and I don't have to have like a pin or anything holding those in. The other benefit is that when I go up to the center goal, I can just pull the intakes out like this, drive up, then bring the intakes back around like that, and it's able to just intake balls out of the goal. A system similar to this was used on the VEX U Team PYRO's robot for Tower Takeover. I can put a clip from their reveal up now. They used it for a different purpose than it does here, but it does pretty much the same thing. Yeah. So now on to how it works. We have a sprocket here that the motor is directly powering. And then we have the arm here, right? It has bearings in here, and it's free spinning on the shaft that goes through the motor. There's chain connecting this sprocket here to this on the end here. That way that when this spins in, it spins this in. And then the ratchet that is added on here makes it such that when it spins the other way, instead of spinning this relative to the arm, it spins the arm out. So the way that that works, we have a pillow block coming out of the side of this piece of C-channel here. When this spins this way, this forces this screw to be pushed back this way, which pushes the entire arm back, right? When this spins this way, the screw just clicks over the sprocket and it lets the intake spin in. This is a way to share the motors between spinning these arms in and out and spinning these in. Okay, so now I'm going to go a little bit more into detail as to how this was built. So specifically what I want to take a look at is this part over here, because I did something interesting with the gearing over here. Specifically, what I wanted to show is this system here. These spin with each other right here, but they both free spin on the shaft here, like that, see? The way that I did that, so I have this gear here, then we have the sprocket. These both have one green insert on one side each, and they go together like this, with the green inserts pointing outwards. Then what I did, I took one of the inserts for a 12-tooth pinion gear, and I drilled out the hole in the middle of that. I had to add about this amount of space between these two, right? So if I add that much space on, these are high strength spacers, by the way, there's no more of the metal piece sticking out of that, right? So there's one interesting thing that I did to get around that. I took a shaft and I just stuck that through the insert there. Then I cut up some zip ties. So I just stuffed the little zip tie bits inside the gear here. Once that's done, I can just slide this back down over here and into there. And it will still stick in enough to grip onto the sprocket here, but it won't go in enough to where this amount of space will stop it from hooking into the next gear over. So now that's like that, there's more than enough. We can just put that right there, right? And now these are locked together. And you can spin this, have them free spinning on this, and let this do the ratcheting based off of this sprocket spinning. To recap, ratchets are systems that allow the transfer of motion in one direction only. There are multiple different kinds of ratchets that can be used for multiple different tasks. When looking for a place to put a ratchet on your robot, you're looking for places where there are multiple subsystems that only have to be powered going one way, and subsystems that don't have to spin at the same time as each other. I hope you found this video helpful, and that you're successful in adding ratchets to your robot for the 2020-2021 game, VEX Robotics Competition Change Up.